Hello and welcome to another episode of Wonders of Chemistry with Mickey G, and today we'll be looking at practice questions regarding balancing equations. And here are our first two equations. So this is the way it's going to work. What I'd like you to do is have a go first by yourselves and see how you fare with regards to balancing these equations. I would suggest that you just press the pause button, have a go, and then come back once you feel confident that you have the answer. Okay, so I'm assuming you've had a go and you want to see how you fared. Well, first question up. Well, hydrogen, we've got two hydrogens on the left, two iodines on the left, and we've only got one of each on the right. So this is a really basic one. We're just going to put a number 2 there, and that balances both the two hydrogens on the left and the two iodines on the left as well. So the equation now is balanced. With the second question, we've got two chlorines on the left and one sodium on the left. Sodium's happy, but chlorine isn't. So we need to place a number 2 here. And now that balances the two chlorines, but we now have two sodiums on the right, which means we've got to place a number 2 for sodium on the left. So both those equations are now balanced. So if that's what you've actually got, great work. Okay, we'll now move on to the next two questions. Okay, so here are our next two questions. Same principle again. I'd like you to have a go, press the pause button, and when you're ready, come back. Great. So let's have a look at how you fared with these two questions. The first question here involves iron reacting with oxygen to give iron oxide. We've got two Fe's on the right, so we're going to stick a number 2 here to balance those two ions on the right. We've got two oxygens on the left, but we've got three oxygens on the right, so we need a number here that when we multiply that by 2 gives us 3, and that number is 1.5, which is awkward, but we'll fix that in a second. So in instances like this, when we get a half in one of the coefficients, we've got to multiply the whole equation by 2. So we'll put that in brackets, and we're just going to say we're going to multiply that whole equation by 2. So the equation will look like this. Okay, great. So here's our balanced equation. 4 ions on the left, 4 ions on the right. 2 times 2 gives us 4. We've got 3 times 2 oxygens on the left, which gives us 6. And we've got 2 multiplied by 3, which gives us 6. So the equation is balanced. Right, moving on to the next question. We've got 1 aluminium on the left, got 1 on the right, got 2 chlorines on the left, but we've got 3 chlorines on the right. So let's tackle this guy. Let's place a 1.5 there. That gives us 3 now. 1.5 times 2 gives us 3. So that balances. Again, same issue though. We've got to get rid of that half. So we have to multiply that equation by 2, which will give us this. Okay, great. So that equation is now also balanced. Okay, so we'll now move on to the next set of questions. Okay, so here we are with question 5, which involves the combustion of a hydrocarbon. Once again, press pause, have a go, come back, and we'll see how you've done. Okay, so let's begin. With hydrocarbons combusting in oxygen, the first step is to begin with carbon on the left-hand side. So here we can see we have 7 carbons, and on the right-hand side, which is the second step, you need to balance the number of carbons on the left by placing a number here. And of course that number is going to be the number 7. Okay, so we're happy now with carbon. Carbons are balanced. The next step is to go back and look at hydrogen. Okay, so how many hydrogens do we have? 16. Now, move over to the right in the next step and ascertain what number you need to place here in order to give the number 16. So something times 2 gives 16. Well, 8 times 2 gives 16. The next step is to work out the number of oxygens on the right. So rather than looking at oxygen on the left, the next step is to focus on the number of oxygens on the right. So here we go. 7 times 2 gives us 14 oxygens in carbon dioxide, and 8 times 1 oxygen gives us 8. Okay, so if we now add 14 to 8, we'll get 22. The next step is to go back to the left and look at what number we need to place here in order to balance those 22 oxygens on the right. So you need to divide that 22 by 2. So 22 divided by 2 gives you 11. Okay, so we don't have any half numbers here, which is great, which means that the equation is now balanced. If we did have a half number, we would have to take another step and multiply the whole equation by 2. But in this particular instance, the equation is balanced. So just to summarize, we've got 7 carbons on the left, 7 carbons on the right, 16 hydrogens on the left, 8 times 2 gives us 16 on the right. And finally, oxygen, 11 times 2 gives us 22 on the left. And we've got 14 oxygens within carbon dioxide, and we've got 8 oxygens within water. So in total, we've got 14 plus 8, which gives us 22. So the equation is balanced. Okay, so what we're going to do now is move on to question 6, which is a little bit more complicated, again involving the combustion of hydrocarbons. So here's question 6. Press pause, have a go, come back, and together we'll go through this. Great, okay. So once again, we begin on the left-hand side. How many carbons do we have? We've got 5. So moving on to the right, we need to put 5 carbons to balance the number of carbons on the left. Now we move back to the left and we count the number of hydrogens. We've got 10. Moving to the right, we've got 2. So we've got to place a number here that multiplies that 2 to give us 10. That's going to be 5. So 5 times 2 gives us 10. The next step is to calculate the total number of oxygens on the right-hand side of the equation, beginning with carbon dioxide. 5 times 2, and finally we have 5 oxygens within our 5 water molecules. Adding these together, we have 15. So we've got 15 oxygens on the right. Okay, moving to the left, we're going to take this number here and divide it by 2, and that will give us the correct coefficient to place in front of oxygen. So 15 divided by 2 gives us 7 and a half. 7.5. 7.5 times 2 gives us 15. The issue is we've got a half. So the next step is we've got to multiply the whole equation by 2. So everything in the equation has to be multiplied by 2. So let's have a look at what the equation looks like once we've multiplied each of these molecules by 2. So there we have it. Now we're going to move on to question 7 and then eventually question 8. Okay, so here are our final 2 questions regarding balancing equations. Both involve polyatomic ions. So what I'd like you to do again is pause the video and come back when you have an answer. Okay, great. Well, let's begin with question 7. So in 7, we begin with lithium. Lithium, we've got 1 on the left, we've got 1 on the right. That looks good. Hydrogens, there are 3. There are 2 on the right, so that's an issue. And we've also got an issue with our polyatomic ions. With this type of question, it's really important that we focus on the polyatomic ions first. We've got 3 on the right. It's in brackets. So 3 on the outside says we've got 3 units of phosphate. So I'm going to put a number here that multiplies everything to the right by 3. So now I've got 3 units of phosphate. So I've got 3 units of phosphate on the left, and I've got 3 units of phosphate on the right. Okay, let's tackle hydrogen now. 3 times 3 gives us 9. So we need to have 9 hydrogens on the right hand side. So we need to put a coefficient here that multiplied by 2 gives you 9. So 4.5 times 2 gives us 9. Lithium's fine, 1 lithium, 1 lithium. The equation is balanced, but we need to get rid of that half. So in order to do that, we've got to multiply the whole equation by 2. So it will look something like this. So in summary, we've got 2 lithiums on the left, we've got 2 lithiums on the right, we've got 6 times 3, which is 18 hydrogens on the left, and we've got 9 times 2, which is 18 hydrogens on the right. And we have 6 units of phosphate on the left, and on the right we've got 2 times 3, which equals 6 units of phosphate on the right. So the equation is now balanced. Great, well let's move on to the next question. Magnesium oxide reacting with nitric acid to give magnesium nitrate plus water. So beginning with magnesium, we've got 1 magnesium on the left here, and we also have 1 magnesium here on the right. Oxygen, we've got 1 on the left, we've got 1 on the right. Hydrogen, we've got 1 on the left, but we've got 2 on the right. So what I'm going to do is stick a number 2 here. So hydrogen is now balanced. It also multiplies the nitrate by 2 as well. Recall that when we place a number in front of a compound or a molecule, it multiplies everything to the right of that number by 2. So 2 times that nitrate. So we've got 2 nitrates now on the left. And we also happen to have 2 nitrates on the right. So just by placing that number 2 there on nitric acid, we've actually balanced the equation. But in order to be 100% sure, let's just go through this one more time, beginning with magnesium. 1 magnesium on the left, 1 magnesium on the right, 1 oxygen on the left, 1 oxygen on the right, 2 hydrogens on the left, 2 hydrogens on the right, 2 nitrates on the left, and 2 nitrates on the right. So both these equations are now balanced. So I'm hoping that after you've finished these practice questions and undertaken those earlier tutorials, that you feel a little bit more confident tackling chemistry equations.